Hello learners and welcome to a Natural Sciences lesson. So today we're going to be doing practice questions and application questions that are based on the reflection of light. So let's begin. So beginning with our practice questions. The first question that is given to us is a multiple choice question, and we are required to choose the correct answer out of the 4 options that we are given here. And the question says, when all parallel rays reflected from a rough or irregular surface are not parallel, the reflection is known as. So, to decipher this, we are talking about the parallel rays that are reflected from a rough or irregular surface. Remember that we can have 2 different types of surfaces. We can have a smooth surface, and we can also have a rough surface, or also be referred to as an irregular surface. So when the light rays are reflected off either one of these two surfaces, the reflection is known as what? So now, if we have a smooth surface and the incident rays are coming and striking the surface, they're going to be reflected parallel to each other. So they're going to be reflected parallel to each other. And the reflection that you're going to be getting here is going to be a clear reflection, or rather a specular reflection. So that means if it's on a rough or irregular surface, it cannot be a specular reflection, because that is a clear picture that we are seeing from a smooth surface. So if it is now on a rough or irregular surface, we know that our incident rays that are going to be striking that particular rough surface, they're going to be scattered in different directions. And because they're going to be scattered in different directions, they are not going to give a clear picture. They are not going to be giving a specular picture. However, they're going to be giving a diffuse reflection. So the reflection coming from the rough or irregular surface is known as your diffused reflection. So the answer here is C. Diffused reflection. Next question. The angle between the normal and the incident ray is called the something. So one of these 3 options. So we need to know, when do we get a normal and when do we get an incident ray, and where do these things apply? Where do we find them, both of them? So we do know that the normal, the incident ray, and also the reflected ray, we all find them in our ray diagram. If we were to draw a ray diagram, we would have an incident ray coming from the source being a luminous object, and then this particular ray, it is going to be reflected, or it's going to bounce off the surface onto the observer. So this is your incident ray. Incident ray, this is going to be your reflected ray. It's going to be a reflected ray. Then in between those 2 rays, there's going to be a normal or an imaginary line drawn in dotted lines that is always drawn perpendicular to the surface, if this is your surface. Now, the angle between the normal and the incident ray, what do we then call it? So that normal line that is drawn perpendicular to the surface helps us to measure the 2 angles that we find in the ray diagram of reflection. We know that we are finding the incident angle, we're also finding the reflected angle, or the angle of reflection. Now those 2 angles, the angle of incident, we are finding it between the normal line and also the incident ray. So our angle of incident is going to be somewhere there, and our angle of reflection is going to be somewhere there in between the normal and the reflected ray. Now remember that those 2 angles, they are equal. The angle of incidence and the angle of reflection, they are equal. So the angle between the normal and the incident ray is called the angle of incidence. It is between the normal and the incident ray. So our answer is also C in this case. So if now the angle of reflection, if you're talking about the angle of reflection, that is going to be the angle between now the reflected ray and the normal. So however, those 2 angles, the angle of incidence and the angle of reflection, they are equal. So question 3 says, substances which transmit most of the light, remember, transmitting, allowing light to pass through. So substances which transmit most of the light and only absorb or reflect a little bit are called transparent. Transparent substances, they transmit most of the light and only absorb or reflect a little bit. Now, the reason why this happens, the reason why we are able to see objects on the other side of these particular substances, it is because of this, that they are allowing most of the light to pass through and only absorb or reflect a little bit of that particular light. So now, we are asked if whether we can list some of everyday objects which are transparent. For instance, number one, things that you can be able to see through them. We can see through a window, so therefore a window is going to be a transparent object. We can also be able to see through a glass, so that means also that a glass is also transparent. And also we can even talk about a plastic, not a shopping bag, however, just a clear plastic. A clear plastic. So because we can be able to see through these objects, we can be able to see objects on the other side of these particular materials, then these materials are said to be transparent. If they are transparent, they allow most of the light and only absorb or reflect a little bit of that particular light. So therefore, these objects are said to be transparent. Now, another question, this is number 3. So another question says, substances which completely reflect, so completely, remember here it said most, however, here on this question, we're talking about completely reflecting or absorbing light without transmitting any, they are called opaque. So opaque substances or opaque materials, they are completely reflecting the light or they are completely absorb all of the light without transmitting, without allowing light to pass through. So if they are called opaque, can we then be able to list some of everyday objects which are opaque? So if you cannot be able to see on the other side of the object, then therefore that particular object is opaque. Number 1, we can just talk about the brick wall. Number 2, we know that we cannot see through a brick wall whenever, let's say now you are in a different room and your brother or your mother or whoever is in the other room, you cannot be able to see through the brick wall to see what they are doing. So you need to go out of the door so that you can be able to see them, unless if that wall was made of glass, then you can be able to see through the wall. However, if it's brick wall, we cannot be able to do that. And why? Because it's an opaque material, it doesn't allow any light to pass through. We can also think of a table, not a glass table, we can think of a wooden table. At school, we can talk about a chalkboard. At school, we can talk about a chalkboard. So these materials, we aren't able to see through them because they do not allow any light to pass through. They either reflect all of the light or they absorb all of the light without transmitting any of the light through themselves. Now, moving on to the next part of the questions, but before we go to those part of questions, which are the application questions, we're just going to quickly go for a short break and I will see you just after this.